In the previous lesson, we found the Thevenin equivalent of this dependent source circuit using short circuit current and the 1 amp test source. Here, we keep the same circuit but use the third resistance method. Add a 1 volt test voltage source at terminals A and B. First, the open circuit voltage is still Vthevenin equal to 10 volts. To find Rthevenin with the voltage source method, turn off the independent 20-volt source so it becomes a short circuit. Then, connect a 1-volt source from B to A with the positive terminal at A. The terminal node is now at 1 volt. The control current is IB equals 0 minus 1 over 100, so IB is negative 0.01 ampere. KCL at the top node gives 10 IB plus IX equals 1 over 10. Substituting IB gives IX equal to 0.2 ampere. Therefore, Rthevenin is 1 volt divided by 0.2 ampere, or 5 ohms. Now use a second example. We want the Thevenin equivalent seen by the load resistor R3. The circuit has a dependent voltage source of value 2Vx, a 15 ohm resistor, a 2 amp current source, and a 5 ohm branch. The voltage Vx is the terminal voltage across R3 from A to B. Remove the load R3 and find the open circuit voltage. Since Vx is the same as the terminal voltage, write KCL at the top node. Vx minus 2Vx over 15 plus Vx over 5 minus 2 equals 0. This simplifies to 2Vx over 15 equals 2, so Vx equals 15 volts. Thus, Vthevenin is 15 volts. For the short wire method, short terminals A and B, the terminal voltage Vx becomes 0. That makes the dependent voltage source 2Vx equal to 0 volts, so it acts like a short circuit, and the 5 ohm branch also has 0 volts. The 2 amp current source now sends 2 amperes through the short. The short circuit current is 2 amperes. Therefore, Rthevenin is Vthevenin divided by I short equal to 15 volts divided by 2 amperes. The result is 7.5 ohms. The Thevenin model is a 15-volt source in series with 7.5 ohms, feeding the load R3. The pattern is now complete. With dependent sources, do not turn off the dependent source by itself. For a test source, turn off only the independent sources and keep the controlling variable in the equations. For a short circuit method, use Vthevenin divided by I short. Both approaches give the same resistance when the signs are tracked consistently.